Good afternoon, everyone. Welcome to February's edition of our First Friday series. And my name is Whitney Stoll. I'm your DC Post president. And thank you for joining us today on this informative session. Joined by me is Bree Beal and Jim DeMilla, who are moderating our webinar today and will also be monitoring the chat. So we have over 100 registered participants from all over the world. So I know that you're excited to be in this program, as are we. So welcome our guest panelists, Andy Lynch from Academy Energy Group and Jim Meacham from Altair Systems, who will be sharing solving the humidity control problem using new ASHRAE design guide from GSA and DOE's innovation program in technology. So this educational program will share updates from the new ASHRAE design guide and how government supports the development of innovation to promote health, resiliency, sustainability, and energy efficiency, featuring programs from GSA and the Department of Energy. But first, I'd like to welcome you to our First Friday series, which is provided to you through SAME's commitment to offering the AEC community effective training, development, and networking programs. The DC Post is helping sustain the future of the profession with these monthly education-focused sessions to deliver topical and relevant content to our industry. So thank you all for joining us here today as we start our program. But feel free to use the chat to introduce yourself, share your LinkedIn profile, any contact information to everyone throughout the presentation. Ask questions so we can address them during our Q&A portion at the end. Also, this is a lunchtime session for those joining us on the East Coast, so feel free to eat your lunch during the program. So we are really glad that you could join us here today and offer this virtual program to our community, regardless of where you're attending from. And if you would like to save the chat at the end with all the contact information, feel free to go up to slide, go up to file, go down to save, and then click on chat so you can save all the contact information at the end. But let's start with a moment of silence to remember our active duty military, first responders, and all who need our care and thoughts throughout the world right now. Thank you. And please join me for the Pledge of Allegiance. So I pledge allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Now it's time for the main program. So please note that this program will provide one professional development hour from the DC Post. Look for an email with the subject line document delivery from SAME DC and Eventbrite with a copy of our program slides, your PDH certificate, and a list of opt-in attendees who pre-registered for this session. So we are recording this webinar and we will post a video on our website later on. I'm not going to read to you the learning objectives on this slide since most of you saw the same objectives when you registered. Instead, I'm going to introduce to you our featured panelists who will introduce their team to you in just a minute. When I do the introduction, if you haven't done so already, please use the chat to introduce yourself, any contact information, as well as where you're calling in from. This is your webinar series to help you learn about this special topic and help you to expand your business network during the program. And throughout the program, if you have any questions, use the chat to share any comments as well. If there is a particular slide you want to talk about, please share those details in the chat as well. We'll answer all the questions that are in from the chat at the end, towards the end of the program. And now to introduce the speakers. So Andy Lynch with Academy Energy Group is an experienced executive with demonstrated history in developing technical solutions for both design build and energy efficient programs. He's an expert in design management, application engineering, and product selection with significant experience in working with electrical manufacturers and supply of lighting, power distribution, controls, metering, solar PV, and HVAC dehumidification. Jim Meacham is a mechanical engineer and co-founder principal of Altair Systems and Altura Associates. At Altair Systems, a manufacturer of smart HVAC systems, he supports the delivery of healthier air quality, improved occupant occupancy comfort, prolong asset lifetimes, and reduce operating costs and environmental impact. Leveraging skills in building commissioning and energy auditing, Jim brings both mechanical engineering expertise and control engineering to delivering projects that operate with optimized efficiency. So Andy and Jim, really appreciate you both joining us here today. I'll turn the presentation over to you to introduce your team, and let's get this program on its way.
Thank you. I'm going to share my screen here, and just if you can, just let me know if you got it working.
Yep, it's coming in. We can see it.
Good deal. So thank you everyone for joining us today. We do appreciate it. We think we've got a good session here. We're going to get into trying to solve one of the big problems that faces the military, the federal buildings, really many buildings and facilities within hot and humid climates. So away we go. A little bit of what we're going to be getting into today. Introductions. We've introduced ourselves a little bit with Academy and Altair. We're going to go through this new ASHRAE design guide to review that. It's the Guide for Resilient Energy Systems Design in Hot and Humid Climates. We'll talk a little bit about the federal government innovation programs, and then we're going to get into the problem of humidity, some legacy solutions, and then Jim's going to get into the technology of the ADAPT, which is the Advanced Dehumidification Airstream Pretreatment Technology. And then, of course, we'll have time for questions. Just at a quick high level, our company, Academy Energy Group, we're veteran owned, we're service disabled veteran owned. We work in the electrical, mechanical arenas, communications as well, and we provide products and services to solve those problems. Our president, Bill Morrison, is a U.S. Military Academy cadet from '97, and one of the founders of Altair, Jim Johnston, is a former Marine. With that, we're wearing red shirts today for Remember Everyone Deployed, and a special reflection to those 3 soldiers who were killed on Sunday in Jordan. So we did ask for a quick moment of reflection. Thank you. Altair, Jim?
Yeah, thanks, Andy. My background is, as you heard, is mechanical engineering, really focused on energy efficiency. So over the last 20 years, I've spent a lot of time in building, solving operating problems and energy problems. And so that's where Altair was birthed out of, is this challenge around being able to do energy efficient and maintainable dehumidification. So Altair is all about solving the dehumidification challenge in the most extreme environments, marine, salt air environments, where we have really more, precise or even just problems in humidity control. So our team has got a lot of experience coming from the field and dealing hands-on with these problems. So that's kind of the background of where our product suite comes from. I'll talk a little bit more about that later.
Thanks, Jim. So real quick, so this is a new design guide. It was published by ASHRAE. It was developed by the U.S. Army Corps of Engineers. Jim and I had the pleasure of being able to collaborate with industry and with the U.S. Army Corps of Engineers. That's CERL, the Construction Engineering Research Laboratory out of Champaign, Illinois, that put the design guide together. The editor was Dr. Alexander Zurhoff, very well respected within ASHRAE and within the industry. One of the things that I think he did that was very intelligent was not only did he get collaboration from industry and end users, all the content that's in this design guide was then reviewed and commented by ASHRAE, and then ultimately, became an ASHRAE publication. The design guide, you'll see, this is the UFC for HVAC. If you were to go to the whole building design guide, you can actually get through this link, the guide there. It's available, for your use. Just at a high level, what's in this design guide, it's touching upon building system as a whole. Our concentration obviously was in the HVAC chapter. So we're going to touch upon that, but there's some great information in this guide that you can review. When we talk about hot and humid climate zones, we're mostly talking about these OA, 1B, 2A, and 3A zones. You can see the map here. When you get into healthcare and say pharmaceutical and some other sensitive humid climate zones, you're going to see that actually extend further north. We do have a Department of Veterans Affairs project that was completed in Massachusetts. In the design guide, some of the things that were identified as hazards in these hot and humid climate zones is, it's high ambient temperature, humidity, and dew point. When another special concern is, as Jim mentioned earlier, is when you have coastal areas, the salt-laden air causing damage and corrosion to systems. One of the big problems that industry and end users have had is dealing with mold. So when you have high heat, higher relative humidity, that equals the ideal conditions for mold to grow. And this is, kind of how mold grows. This is the spore lands on a surface, it germinates, you add moisture, it's going to grow. And that moisture can come from the condensation from the humidity. The U.S. Army, this was published in armytimes.com by Jonathan Learfeld, found that over 2,000 facilities had issues and problems with mold. So we are trying to do what we can to help to solve this problem. There's many health effects that are caused by mold, several here that you can see, and this can be a serious problem. It can cause some serious health issues for people, and we want to do what we can to protect and serve our service members and others in these indoor environments. Some of the other issues that we'll have is corrosion. Corrosion causes premature failure of systems, and it will increase your life cycle costs. One of the solutions for this is humidity control. One of the problems that we just mentioned, corrosion, is such a big problem that there's actually a corrosion policy and oversight committee that deals with and studies this topic. One of the things that they've found is that this corrosion, the impacts of corrosion and the costs associated with corrosion has increased dramatically over several years. What can we do about it? Well, in the design guide, when we take proper design plus resilient equipment specification with communicating all the operational requirements of the facility, your sequence of operations of how the facility is going to operate, and put a little bit of maintenance in that, we can protect the facility with the HVAC that the envelope can't do on its own. The systems really need to work together, the envelope with the HVAC. So the solution that we've come across is pre-treating the outside air. You're taking that hot, humid air and you're dehumidifying it before it goes into the air handler. So this is a solution for chiller and air handler type situations, and we're solving the problem. We have been recognized for this with an award from the GSA Green Proving Grounds. It's an innovation program with GSA and Department of Energy, where they take innovative technology, they will implement it into facilities, and then produce results for the industry so that they can find solutions and best practices to share with the world. In 2021, Academy and Altair joined forces to win this award for HVAC dehumidification. The project is in process here still with down in Lufkin, Texas. You see the courthouse here, and they actually have a boiler that's running year round. So there's an energy savings play and a facility improvement play with this technology. It is also under study with Department of Energy with the High Impact Technology Program. This is with the project that has been completed with the U.S. Navy down at NSA Orlando. So there's 7 pretreatment systems that are up and running, fully commissioned and operational, and the instrumentation is in place, and we'll be collecting data once some of the other work within the facility is complete and ready for a pre and post assessment. From there, want to give it to Jim Meacham to tell you a little bit more about this technology that is solving the problem for HVAC dehumidification. Jim, can you take it from there?
Yeah, absolutely. It's great to be here with everyone. Hopefully we can shine a little bit of light on this conundrum. Dehumidification and humidity control is a challenge in the industry. So I'm looking forward to some questions from everyone. I want to just a level set with the crew that we have here. Two concepts around this that are really important are latent and sensible. What does that mean? So latent cooling is the dehumidification aspect. Latent is the phase change component where we're removing water from the airstream. So typically how this is done in an air handler is, the mixed air from the return and the outside airstream flows across that cooling coil. It's subcooled, which just like, when you have your cold water glass, the water condenses on the outside. Similar here with these cooling coils, water migrates out of the system and flows down and out of the unit as liquid condensate. That's the moisture removal piece. There's also the sensible piece, which is the temperature change, really. And I think of sensible really directly related, to that temperature in the space, that occupant comfort. So that's the heat removal component. So those are important concepts here. So next slide, Andy. So why is humidity control often so challenging in our building systems? And I'm going to focus specifically on chilled water based systems here. Direct expansion systems have similar challenges. So here you have a typical recirculating air handler. This could be a variable volume air handler or a constant volume air handler, but you have your return airstream coming in from the top there from the building. You have some fraction of outside air, and in our hot, humid, and mixed humid climates, that's at least in the summertime and sometimes all year round, warm, humid outside air that's introducing this moisture into the system. We need that outside air for ventilation, obviously, but it's also introducing this moisture stream and potentially salt stream as well into our unit. We're using the cooling coil here to dehumidify that, and then we're sending that air out that's in a subcool condition because we needed to cool it down to dehumidify it. So one of the things that we see right off the bat is that often in practice, our cooling coils that do this dehumidification are really undersized for the worst case conditions. It's a trade-off of cost. ASHRAE selection, you're either selecting at 0.4% or 1% of the time to miss. So you're going to miss some. And the other thing that we often see is that these coils really, when they're really wet in deep dehumidification mode, they don't perform as well as we expect them to because they have a lot of water on them. So this cooling coils being undersized or kind of not having the total capacity leads to a lot of issues. Namely, the most common thing that we've seen in practice over the last couple of decades is operators then have really no choice in their minds of, but I have to reduce that outside airstream. That's what's inducing my issues on the load on this air handler. So I'm going to close my outside air dampers a little bit or all the way, and then my load issue goes away. I'm now able to maintain the right supply air temperature, and I'm not pumping a bunch of humidity in my space. The problem with that, of course, is now we're not ventilating the space properly, which has all kinds of health and productivity components to it, especially sensitive now post-COVID. And we've just made the building negative. So we're actually going to be sucking that air in now uncontrolled through the envelope, which can lead to all kinds of other downstream implications. One of the other things we see in practice in a lot of these typical mixed air handlers is you've got really high air velocities coming off these cooling coils, and that's really true when that cooling coil is wet. So imagine this cooling coil doing a lot of dehumidification on a humid day. water is evolving off the coil, and that water has to physically move off of the coil, and it gets stacked up on the coil. So it starts to accumulate as it's moving down. That reduces the available net free area of the airstream. So our effective face velocity goes up under those dehumidification conditions. So what happens is we start to see the water droplets from that coil get re-entrained into the airstream downstream of the coil, which might go into the fan if it's a draw-through scenario, and then be re-evaporated into the airstream, which kind of reduces our dehumidification effect, or just causes mold potential issues downstream of that coil. So carry off is a really a bad thing to have in an air handler. One of the things that we often see as well is, and was evident in the photo from the Army article that Andy mentioned, is, you know, this cold saturated air is getting sent down into the spaces. So this air, best case scenario, is about 90% relative humidity, upwards of 100%, depending on that carry off scenario. Most of our air handlers don't actually have a reheat coil here, or it's not used. So that saturated air can cause a lot of problems down in the space. For mold to grow, actually, it doesn't have to be fully condensed. Mold can grow in just very high relative humidity environments too, like 90+%. So not all the time, but a lot of the time you look up at those registers and you see the black stuff. It can be mold. Sometimes it's just dirt, but a lot of times it is the beginnings of mold because of this high relative humidity coming from the systems. So how this manifests in the spaces, you know, a lot of times we see either overcooling. I think all of us have been to buildings, particularly in the Southeast, where you go in the summertime and it's really cold and clammy. You're like, why is it so cold when it's hot outside? And it's really because they have to for dehumidification, and they don't want to use reheat. So the trade-off is we either have to use a lot of reheat energy and maintain the comfort. That's how these systems are historically designed. There's a lot of these out there. It's like, yeah, we have to subcool and reheat the air. So very high energy cost scenario. So it's a trade-off of either we don't want to do a lot of reheat to save energy and energy costs, or we're going to do it properly and we're going to spend a lot of money doing it. It's very inefficient. So that's kind of the baseline of how do we get here for, you know, 80% of our systems that are installed out there in the field. Who can move on here, Andy? Of course, there are, and I've been involved, you know, as an energy efficiency practitioner over the last couple of decades. There are a lot of market solutions out there that attempt to solve this problem. There's runaround coils, you know, whether that's a refrigerant based or a pumped runaround coil, like you see here in the upper left. There's energy wheels, total energy or sensible energy wheels for reheat. There's, you know, on the bottom here, bottom left, I can't tell you how many thousands of portable dehumidifiers I've seen, particularly in barracks applications, you know, megawatts of these things out there to deal with dehumidification challenges. We talked about closing the outside air dampers. Bottom right here is a picture that I took in Korea, where the humidity control was so bad in the building that mold was growing under the wallpaper. So there's solutions and challenges that we see in the field here, and it's our kind of thesis has been the solutions are just way too complex that are out on the market. We need something simpler. So that's where we came up with this concept of the ADAPT unit, the Advanced Dehumidification Airstream Pretreat technology. So pretreat being the objective term here. So this is kind of just taking the philosophy really that ASHRAE has been pushing for a long time, which is, hey, we should decouple latent and sensible cooling. If you think about it, in the traditional air handler scenario, at the air handler level, you have one control surface, typically, that's the cooling coil, trying to do two things. It's trying to control both the latent cooling and the sensible cooling. So it's trying to control the humidity levels and the comfort levels at the same time. For those that are into control theory, you know that trying to control two variables with one control surface is not possible typically under most conditions. So you have all these trade-offs that we talked about. Our approach here is to decouple that, much as ASHRAE has been pushing. So you've seen this move over the last decade towards things like chilled beams and fan-powered induction unit boxes and dedicated outside air systems, which is really about this decoupling concept. What our solution is really aimed at is, let's be able to decouple, but still use a traditional VAV reheat or VAV design at the air handler level. I'm a proponent of the recirculating air handler design compared to some of these induction unit solutions for a variety of reasons, not the least of which is ventilation control and air filtration, which is often much superior on a recirculating system compared to some of these other systems. So this allows us to achieve that decoupling of the latent and sensible in a retrofit application or a new construction application. But really our thinking was, let's make it easy to retrofit, because there's so many of these recirculating air handlers out in the world. We're not going to be able to replace all those air handlers with a huge new thing with runaround coils and energy wheels, and it's never going to fit. So we need a solution that can attack that. So that's where our ADAPT unit was born. So the idea, as you can see on this is, hey, let's be able to drop in this unit, very simply connect the ductwork up to the minimum outside air section. We can pipe right into the chilled water connections. I'll talk about how that's possible from a load perspective. So you pipe those up. We've got all the controls on board. Andy mentioned my background in controls, or maybe Whitney did in his intro. I very much believe that we need to make it easy to apply this. Dehumidification can be a kind of an unknown quantity in the field application for controls. So we do all that at the factory. So it's just plug and play, very easy to apply, can integrate to the BAS, to interface for the alarms and all those things very easily. But the hard work of how does it work is done on board our unit. So you just bring it 120 volt power and you go. So what happens here is that warm out humid air, now we're dehumidifying it, deeply dehumidifying it, doing all of the dehumidification of the system at our unit, then mixing it with the return air. Now all the air handler is trying to do is optimize its supply air temperature to the space to maximize comfort and energy efficiency. And it's not having to do two things at once. It's really, how do I maximize thermal comfort because my dehumidification is being done upstream.
Hey, Tim, can you touch upon, at Navy, there was a good example of how you were able to increase the airflow, the ventilation, while still being able to save energy. Can you touch on how that works?
Yeah, for sure. Yeah. So, one of the challenges that we see in practice too, one is we often see that spaces are significantly underventilated in practice. We talked about that. I was actually involved in a California Energy Commission study a little over a decade ago that was looking at comparing actual ventilation rates to design 1 to 3 years after facilities were delivered. So we went and surveyed dozens and dozens of systems a few years after they were constructed and say, okay, well, how are we actually doing from a ventilation perspective a few years on? And what we found was that a majority of those systems were significantly underventilating compared to design, 20 to 100% under design. And that's a common issue in the field. And so combine that with now, especially post-COVID, a lot of folks are a lot more sensitive to what is my actual ventilation rate, and I want to come up to code. So for example, at the NSA Orlando project, they wanted to bring the building up to current ASHRAE 62 ventilation standards, and it was designed, I think, in the early 80s, 84 or something like that. So it, compared to today's ventilation standards, very low ventilation comparatively. So it actually, on a design basis, doubled the ventilation rate for the facility. So it went from like a total of 17,000 CFM to 34,000 CFM of outside air. Well, the air handlers are in pretty good shape, and you can't just double the outside airflow rate. Not to mention that they were significantly underventilating there as well before the project because of humidity issues. So what our solution was able to do is say, you can kind of have your cake and eat it too here, which is we can give you the capacity to double your outside airflow rate, and we're going to make the system more efficient. And it's kind of twofold here. One is around the delta T of the chilled water system, which is often a challenge in these large chilled water systems. So the supply temperature compared to the return temperature, we want that to be 10, 12, 16 degrees, depending on the design. Often it's operating underneath that level because of the realities of controls in these systems. Same was happening. We had like an average delta T of something like 7 at that facility, which was under the design, I think, of 12. So our unit has a very high delta T. I'll talk about that a little more in terms of the coil design. And not only do we have a high delta T, it also increases the delta T of the downstream system. So we get a lot more capacity back from the chilled water system while enabling all that energy efficiency from the supplier temperature reset, which I'll talk about in a minute. But the thing to take away from that example is we actually reduced the chilled water flow rate, the peak chilled water flow rate of the facility, even when we increased the outside airflow. So we increased the load. They had plenty of chiller. We increased the load, but we reduced the chilled water flow rate because of the better delta T performance, which can be a limitation in these. You've got existing pipes. We couldn't go through and upsize all the chilled water pipes, right? So increasing the delta T is a big deal. Getting geeky here. Here's the psychrometric analysis. Actually, Andy, let's not go deep into that. I'm going to show this a different way. If you go to the next slide, I think. Oh, we didn't include it here. Sorry. Go back. I'll walk through that. I apologize. We have a kind of conceptual way of looking at this too in a different deck. This is an operating room example, 25% outside air, but you can see what's happening here. This is really illustrating the reheat piece. So starting on the upper right is our outside air that would be coming into the unit. It's 25% of the airstream in this case, so 2,500 CFM out of 10,000 total to the space. Dehumidification happens when we cool. It hits the saturation line, and then all of that's going down and to the left is our latent cooling, which is bringing the water out of the air, right? So we bring a lot of water out in this case from that outside airstream, and then you see the reheat that happens that's on board our coil. Our coil design has integrated chilled water reheat into it. So essentially, it is the warm chilled water that would be leaving the chilled water coil. We've got a very specialized design of that coil that's made for deep dehumidification and energy recapture, such that instead of sending 47-degree air, which is what our target here, 46.8, you see the dew point, that's what we're subcooling it to dehumidify. We're not sending that 47-degree air into the back of the air handler, which could be a challenge from a condensation perspective in the mixed air chamber. We're actually going ahead and reheating that up. In this case, based on these conditions, it reheats up to 60 degrees dry bulb. So it's a lower relative humidity. So we're not near any condensation lines. We mix that with the return airstream. In this case, we do a little bit of sensible cooling. We go from 63.7 degrees back down to 60 based on the load in the space, the equipment loads and people loads. And that's where we hit our target temperature of 65 in the space at a 49-degree dew point. So it kind of illustrates the importance of that reheat to basically make sure there's no condensation when we mix that super subcooled 47-degree airstream in this case with that return airstream. And here's some data from the field looking at the coil performance. So you can see this is from NSA. The blue line at the bottom is our leaving dew point of the outside airstream. And you can see how that maps to the actual leaving dry bulb temp, which is that orange line there in the middle. and you can see we're going well above, we have a big delta above those, so we have a low RH. You can see how that changes based on the changing entering air conditions. So this is from roughly like 80 degrees and nearly saturated on the left, all the way to a lot warmer conditions, and we're maintaining a higher leaving dry bulb temp than our dew point temp, which gives us that lower RH and reduces that condensation potential, which is a key part of being able to mix that air, that super subcooled air, into the back of the air handler without causing a bunch of problems. I see a question here on the pressure drop. This is a great question. Our baseline unit does not use a fan. Our preference is to not add a fan to our unit if we can get away with that. It depends on the system. So what we do is we look at the existing systems and we see how much pressure drop is available in the mixed air section based on the fan and system curves. And so we can characterize that very easily based on maintaining the differential pressure and looking at what type of negative pressure we can get in that mixed air section. So some applications we will have to add, and we've had to add a fan to our unit to overcome our pressure drop. Our pressure drop, our clean filter pressure drop is about 0.75. So for us, dirty filters are pretty low on the pressure drop because we have low phase velocities. So call it 1.1, 1.2. So in the case of NSA, the fans had plenty of capacity to overcome that pressure drop. We've had other applications where we've added a fan to make sure we can maintain the proper flow across the coil. It's a great question. We've designed our system. One of the attributes of the system is it's got a low face velocity. Because our system is really a latent machine, we only care about doing latent work on our machine, right? So we have very low face velocities on the filters and the coil, and we do a lot of dehumidification. Our typical heat ratio in most applications is like 0.25. So it's really a latent machine. So we're able to have these really low face velocities and really focus on that latent removal.
Jim, we got about 7 minutes left.
Yep. Maybe we'll see this. Let's breeze through this. This is some of the concept diagram showing how the adapt is transforming that incoming stream. And basically you can see, I think the thing to highlight here is, on the typical air handler design, when you mix the outside air and the return air, you're above the dew point that you're trying to hit for your leaving air, right? So we have to subcool for dehumidification. With the adapt system, we're able to hit that dew point temperature before the cooling coil. So now we don't require any dehumidification. It really is all about what dry bulb temperature do we need to leave the system to maintain our comfort, our space thermal comfort. In this case, this is like the peak sensible day. So we say, okay, we've got to send out the design conditions, 55, 56 degrees, right? That's a few hours a year. But most of the time, you don't need that design condition. Most of the time is a part load time, whether it's morning or afternoon or April versus July. So the typical design is either overcooling because it has to do that dehumidification all the time, or it requires reheat. And you can see with adapt, we can make that discharge temperature essentially anything we want up to 70 degrees, the mixed air dry bulb temperature. Actually, you get a little fan heat, so you can go a little above that. And in practical terms, I think if you go to the next day, I don't know if we had 2 or 3 of those, but that illustrates the energy savings potential is really in that supply air temperature reset, because now we can go to whatever we need to. And what we're seeing, for example, at NSA Orlando, is that building wants to be up at 65, 68 degrees most of the time. It's just the design of the systems and the VAV flows, and it doesn't require 55 degrees hardly ever. And so, we're able to save a lot of energy because we don't have to send that 55 degrees all the time.
Yeah, speaking of energy, Jim, can you touch on the energy modeling that NREL had provided?
Yeah, absolutely. So we've done a lot of modeling with NREL on system performance. And so this is an example where they built an Energy Plus model using our system performance data that we've got from the field. And you can see the types of savings that we're talking about here in natural gas and cooling electricity. You know, whole building, we're saving 16% of the KBTUs. And on the HVAC side, if you focus on that, 30 plus percent. And this is for a building that's not running 24/7, and is a scheduled 10-story office building. So there's a lot of energy savings to be had, particularly like a lot of these buildings in the South run 24/7. And go to the next slide.
Yeah. And can you touch on the night and weekend mode of how that can save energy too?
Yeah, that's a good point. Yeah, so we do have one of the things that we've built into our unit. A lot of these buildings in the Southeast in particular, but other humid climates, they really can't. It's very difficult to turn off at night because you have this moisture incursion that happens through the envelope, right? And it's just moisture moves quick. So we have a mode in our unit that allows us to significantly turn those systems down while still keeping the building pressurized with outside air. And we can kind of like lose the sensible component of it. We don't really care because we can recover quickly as long as we don't have a bunch of moisture in the space. So we can, for those buildings that are running 24/7, and this is going to be something we're going to implement on NSA at some point. It's been running 24/7 forever because of this control issue, or they can't control humidity. But now we have the ability to. So the facility isn't operated 24/7, and we can go into use this night setback mode, protection mode, to save a lot of energy in the system.
Hey Jim, I'm going to move us along real quick to the sizing piece because we got just a few more minutes. Sizes of the units, the 2,500 to 5,000 to 10,000 CFM, and if you can touch on how this impacts new construction from a sizing standpoint.
Yeah, absolutely. So, we've talked a lot about retrofits and energy efficiency kind of applications. It's also, for like major equipment replacements and new construction, it's a good application too. When we use our unit, we're taking all that dehumidification off the other unit. And so we can significantly downsize the coil and we can increase the face velocity of that air handler. Here's an example of that. So this is actually a replacement project we looked at in the DC area where we had these existing 25,000 CFM roughly air handlers. They needed to be replaced. They were in these mechanical rooms that were essentially inaccessible. And so it was going to be a really invasive knockdown construction kind of thing to fit these air handler parts in piece by piece. And when we're done with that, it would just be the same thing it was before, right? Just a VAV reheat air handler that costs a lot. We get electric reheat in this case. If we rethink this and say, well, what if we use the adapt unit to treat that outside airstream? Well, we can significantly reduce the size of that downstream air handler. Adapt's doing all the dirty work of getting rid of the moisture. Our unit's designed to do that. It's made out of marine grade aluminum, so it'll last forever. We've done all the things. Because we're focusing just on a portion of the airstream here, we can spend the right money on that, and then it saves us a lot of money on the downstream air handler. So we can increase the face velocity of that downstream air handler because it's not going to be wet anymore. And we can now, in this case, we make that make a sectional unit that we can take in through the standard door and bolt together as opposed to knockdown. And we get all that supply air temperature reset optimization and energy efficiency from the delta T, which saves a lot of operating costs. You can see we cut the operating costs in this case in half.
So Jim, we're just at about the time. Just a few more quick points that we want to get across, if you can, and just real quickly touch on the integrated heat recovery.
Yeah, I mentioned this. This is kind of a conceptual view of our coil. It's like a super desaturation coil. It really is one coil with integrated tubing, but you can think of it as kind of coils in series where we clean the air with filtration, we dehumidify the air. We take that warm, chilled water that would normally go back to the chiller plant and have to get cooled down all the way, and we use it to reheat the air so that we get off of that saturation point. And again, that's to make sure we're not fogging or having any potential for condensation when we mix that in the back of the air handler, which would be you would make a mold machine, which is why we don't see people just hacking cooling coils into outside air streams behind air handlers.
Yeah, and just to touch to close out on a few quick points, the unit is available also as a DOAS unit. You can see this example here, so recirculation and or DOAS. Here's a photograph of a DOAS that was installed for the U.S. Department of Veterans Affairs up in Massachusetts. So we're at just about the time here. Here's our contact information, and just as a piece of future topics or interest, I know that there's a lot of interest in indoor air quality, and we can solve that with a holistic methodology. Oops, there we go. Sorry. So for future topics, looking at a holistic approach to indoor air quality, HVAC, we can support that as a future topic, providing a roadmap to improve indoor air quality and save energy. Thank you.
Oh, hey, Andy and Jim, thank you very much. You can leave this slide up for a second, so everyone who is in attendance can make sure they jot your information down. Again, definitely appreciate the conversation, and if anyone has any questions, please feel free to drop them into the chat, and so we can talk with them, address them with Andy and Jim. So I have a quick question off the top of them. You mentioned you've done the Green Proving Ground projects, but you've also done the VA. Has there been any similarities or anything you've seen really unique across each individual agency, or a common theme you've really seen what doing these projects with them?
Jim, why don't you comment first?
Yeah. I think the main thing that where we got engaged and they're reaching out to us is we're really challenged by being able to solve this humidity problem, and the traditional solutions won't work for us for whatever reason that is, or they're really concerned about the maintainability of the systems and they don't want to put some desiccant system in or something that they're already struggling with normal maintenance, and adding complexity is a bad thing. So that's really I think one of the main themes that we're seeing in the industry that really drives that. The other one is the desire to have open controls and the controls integration. So we definitely support that, and we demonstrated that on all the projects so far, that hey, we can easily integrate, you get all the data you want, and alarming and all those things, so that even though we're doing a package controller, you can really get all the data and have all the insight.
And some of the feedback I'd say that we've seen is a huge amount of interest from the end users. It is a new technology, a couple of years old, and there have been implementations, but really the request from the agencies to, for us to educate the engineers about the new technology, the contractors, about this technology, the design build contractors, the energy service companies that can utilize this for, energy savings performance contracts. So really just getting into the education and awareness. And so we're grateful that, you've provided this platform for us today to work on that. And we're going to continue to share what we think are some of these best practices, and, try to help people solve this problem.
Great. We have a question from, we'll address Tom's question first. So do you see chilled water pipe size reductions and less pumping when you're using this type of concept, this system?
Yeah, it's good question. For new construction applications, yes, we believe you can reduce the size compared to your typical air handler design, just based on delta T performance, right? So the flow rate is linearly related to your delta T. Our delta T is 17 plus. And given that we're also going to keep the downstream air handler dry coil has a better delta T. So those air handler delta Ts are going to improve as well. So, you design for that in your new construction application, you can reduce the pipe size. On the existing applications, it's really about making sure we can get the capacity out of the existing systems. We often see existing systems running out of capacity, right? It's a big challenge. It's super expensive when you get into replacing chilled water pipe. I mean, you really don't want to be there, especially from for me coming from the energy project world. That's a good way to kill energy projects. So us being able to give that capacity back to the existing system, like that NSA example of increasing the outside airflow rate, doubling it. Actually, in practice, it went up by about 7 times. And yet we reduced the peak chilled water flow rate. And we've seen that. I mean, the chilled water pumps are operating at 55%, 60% all the time now. I mean, it's really low. So it's pretty impressive.
Robert has a quick question. Could you go back to the VA hospital? There we go, for a size reference.
Yeah, this is a 10,000 CFM unit, 100% outside air with you see the preheat coil. Looking on the left, we have an integrated preheat coil in this unit as well. And this unit does have fans. Obviously, it's a DOAS unit. We use a fan wall, so it's got a 4-fan wall in it. And this unit also has humidification along with our dehumidification system. So it's really like total humidity control here.
And Robert, we'll send out the slides after this, so you'll be able to look at them in more detail. And I believe you did have a prior slide that kind of had the different sizes, correct?
Yeah.
Okay, yep. Great. Yep. Tom has a question on: are there any competitors out there, or does this need to be can this be a sole source justification to be used on projects?
Yeah, I can take this one, Jim. So we've actually met with some subject matter experts of mechanical. Tom Adams, SME for Air Force. We did a thorough review with him, and the technology and the approach is consistent with the current UFC. We've seen different agencies approach their specifications for projects a little bit differently. Some have been performance-based narratives, some have been a basis of design or equal. We have a continued conversation with each of the agencies about this. And yes, you can sole source the project, but that takes the justification, as you know. And as far as competition out there, can't really comment on competition. It is a unique approach of the pretreatment of outside air. We have it installed and up and running. So if you have more questions on that, I can, Tom or anyone, I can help you with navigating specifications.
Well, great. If there are no further questions, I definitely appreciate it. If you have any questions afterwards, or ones that come in, feel free to reach out to Andy or Jim, and they do have their contact information in the chat. And again, if you arrived late, feel free to go to File, down to Save, and save the chat, so you'll be able to see all the contact information. And Robert, can you include recommended specs with the slides? If they're not already preset in the slides, Robert, I think that's where you reach out to Andy with his contact information, and you can add those specs for you. Yeah, just reach out individually to Andy. We had the slides done before this presentation. So, but I think that's everything. We have a few more slides, and then we can wrap this up. But they are willing to stay a few minutes afterwards if any questions do come in. But again, Jim, Andy, thank you very much for everything. Definitely very, very informative. I have done the Green Proving Ground program in the past. I think it is very impactful and informative to see what we can do to always improve our overall federal footprint. And thank you everyone for joining us here today. But before we wrap up our program, I'd like to share with you some of our upcoming events that we do have planned for the next couple of months. So please mark your calendar for some of the local post events, as well as some of the upcoming national events that we have. So we are committed to bringing you more content and fun events in 2024. So our next First Friday event will be on Friday, March 1st. As always, all registered participants will earn one PDH certificate. Our program is Building Secure Systems, Integrating Security by Design and Risk Management throughout the project lifestyle, with presenters Gus Morales and Bosco Chan from Geodecisions, a division of Gannett Fleming. So registration is open now. And if you're interested in sharing your knowledge on current educational topics for First Friday, we are accepting presentations for summer topics. You can visit our website and submit your topic today. And sponsorships are available if you'd like to support the popular program. On Tuesday, February 20th, join the DC Post as we salute our military during Military Appreciation Game Night with the Caps against the New Jersey Devils. By purchasing a ticket or sponsoring the event, you're helping us donate 50 tickets to our military and enjoy the game night together. We've got 30 seats to gather, build a network, and cheer on the Caps. Ticket holders will get a free DC event t-shirt with our logo and a Caps hat. So we hope you can join us for this fun event. And then join us on April 24th, 2024 for our upcoming DC and Nova Post 16th Annual Small Business Conference. This is our premier one-day conference event that is returning to the Capitol Turnaround near the DC Navy Yard. And we do have a great lineup of government agencies to share the latest opportunities and challenges to help fill up your GovCon pipeline. So build your network and focus on small businesses, teaming and opportunities for this event. So exhibit booths and sponsorship opportunities are available. And Bree, I believe we missed I missed one slide on there. Yes. And then on Thursday, February 22nd, we are doing a joint event with the Blue Ridge Post and the International Stability Operations Association, ISOA. We have a great lineup to focus on doing work with Ukraine and construction projects in Ukraine. This program will sell out. So if you're interested in learning more, please register today. So we do have 4 notable events hosted by SME National that you should add to your calendar. Coming up is our career transition workshop. Virtual sessions have already begun, and then the in-person program is going to be held in Maryland in mid-February, so February 14th through the 16th. So this event will be those who are looking to leverage their skills and accomplishments of transitioning from the military, as well as those in the military or civilian government that are looking to start a career in the private AEC industry. It's a great program to help us support our industry. And Capitol Week is just around the corner, held the last week of March. So get your tickets for this event, where you can meet leaders from our government agency to get an outlook on the latest policies and opportunities aligned with congressional budgets and initiatives. So you don't want to miss this event in March. And do you know a rising sophomore, junior, or senior who is interested in learning a hands-on about the AEC industry? Applications for the STEM engineering and construction camps is now open. Located at or near military installations around the country, your camper has the opportunity to receive a scholarship to attend and learn more about our industry as a career or make lifetime friends. Last year, the DC Post supported 8 campers with scholarships to attend. So don't miss out on this great opportunity and send a camper to a camp. And applications are due on March 15th. And finally, the SAME JETC conference will be held in Orlando on May 14th through 16th. We are looking forward to attend, and registration is open. Bree and I will actually be there with Ed Chamberlain and Anna Ehrman presenting on a panel called Building Your Company Differentiators to Win Big. So we hope you can join us down at JETC in Orlando in May. Make sure you take advantage of the early bird discounts by registering before February 15th. Or if you'd like to volunteer at the conference, you can get a free registration to attend. So learn more at samejetc.org.
Whitney, real quick, I did see a few notes that came across, private notes that I did not get a chance to respond to or address. So
yeah, hey, let me finish up and we can get to you. Be sure to visit our website at same.org/DC post to mark your calendar for any upcoming events and programs, as well as your calendar for some of the national events. We do have 2 upcoming federal luncheons that are going to be happening on climate resiliency and electrical infrastructure in March, as well as our annual June joint conference with ACEC and CMMA on major construction programs, opportunity trends, and strategies. So thank you again to Andy and to Jim for providing excellent content for today. And please be on the lookout for document delivery in the subject line with your PDH certificate and the opt-in list of attendees. So have a great weekend. And Andy, I believe you just had a couple of things you would like to address. Other than that, thank you all for attending.
Yeah, I just wanted to say, for anyone that sent me a private note, I apologize if I didn't get a chance to respond. If you send me an email, we can chat and take care of your questions and needs. So thank you for the notes. Thanks for the time. Appreciate it.
Everyone have a great day. Thank you.
Thank you all.